In the first section of the DVD, we talked about ambient lighting, diffuse lighting, and specular lighting. And I went over the code that's involved in generating those three elements of the lighting model. Now, ambient, diffuse, and specular, the way that we've talked about them so far, all combine together to create the Blinn lighting model. There's a fellow by the name of Jim Blinn that invented this math for how to calculate ambient, diffuse, and specular lighting. And so we call this the Blinn lighting model. So what we want to talk about in this section are other lighting models. And first, I think it's important for us to understand what a lighting model is. A lighting model is the math that figures out what color each pixel on the surface of the model is based on the parameters that we have to use. And I think that, we've already talked about some of those parameters, like we have the light vector, the surface normal, the view vector, the eye vector, and we can have other parameters to input to that as well. But all those parameters need to combine some way to calculate what the final color of the surface is. And so the method that we've talked about so far is called the Blinn lighting model. So like I said, in this section, we're going to talk about a couple of alternate lighting models and ways of simulating surfaces that have different surface properties than just the standard Blinn lighting model. The first lighting model that I want to talk about is a relatively simple variation of the Blinn lighting model. This lighting model is called Fong. And the Fong lighting model is also named after the person that invented it, whose last name happened to be Fong. And in fact, Fong developed his lighting model before Jim Blinn made the Blinn variation. It just so happens that we've talked about Blinn first, but actually Fong came first. So when we talk about a lighting model, so far we've talked about it in terms of ambient, diffuse, and specular. And there are a lot of lighting models that don't make a differentiation between those three. They actually calculate the entire lighting together with one formula, whereas with Blinn and Fong, they actually do divide things up: ambient, diffuse, and specular. Now, in the case of Fong, the only difference between Blinn lighting and Fong lighting is how the specularity is calculated. So if we want to convert a Blinn shader to a Fong shader, all we need to do is change the way the specularity is calculated. So let's pull up Effects Composer and we'll take a look at our Blinn shader and talk about the specularity once again. So the first thing that we're doing is calculating the half angle. So we add together the light vector and the view vector, and we find this area on the surface that is calculated by adding the light and view vector together and normalizing. And so that gives us our initial zone or area on the model where specularity can potentially be. And then we do our dot product between our half angle and our normal. And it's actually this dot product that's giving us that zone. And we saturate it so that we don't get a result that's less than 0. And then we compute our glossiness, and the glossiness is used to raise our n.h term to a power. And raising it to a power, this is what actually narrows that cone down so you get a really sharp specular highlight. For example, if we take a look at our teapot here, and we've got our glossiness at 35, but if I crank it up to 256, this is going to narrow that down. This is raising it to a power, and you get a really nice, tight specular highlight. So jumping back to Effects Composer, once we have our tight specular highlight, we multiply that by our specular color and our specular texture. So that is the Blinn variation of the lighting model. And the main difference between Blinn and Fong is this term right here, calculating the half angle. If you think about what a specular is, what is a specular highlight? Well, if you have a light, like a light bulb in a room, for example, and it's shining on a shiny object, what produces the specular highlight on that shiny object? Well, it's the light source reflected in the shiny object. It's actually a reflection Now, it's not a mirror reflection because you're not getting reflection of everything. You're only getting reflections of the very brightest things in your scene on most materials. And so that is what is creating your specular highlight. So specular highlights are really just kind of a hacky way of imitating what reflections do. So if you're going to do specular highlights the real way, you'd actually use a reflection map, and you'd have a high dynamic range image that you were reflecting, and your reflection value would be cranked really low so that your object only reflected the brightest parts in your high dynamic range reflection map. Well, that's kind of an expensive way of going about things. We talked about doing diffuse that way. When we talked about global illumination, we're using our diffusely convolved cube map, and that's how we calculate our diffuse lighting. Well, we could also apply the same principle to our specular lighting if we wanted to. We could use a mirror reflection cube map, but then only reflect the brightest areas in that cube map. But there's some downsides to that. You have to have your shader has to be using high dynamic range, and you have to have high dynamic range reflection maps, and you have to have reflection maps that are fairly high resolution. And so Blinn Specular and Fong Specular are fairly good ways of approximating the reflection of the light source. But that's all they really are. They're just approximates. They're not real reflections. And Blinn is, I guess, it's less of a real world scenario than Fong even. So as I said, the difference between Blinn and Fong is in this half angle term. So if we wanted to convert this Blinn shader to Fong, we would take out our half angle. So I'm just going to comment this out. And instead of calculating the half angle, what I really want to do is calculate the reflection. So if we think about our light vector coming in from the light source, it's going to hit the surface and reflect in a certain direction. So we need to calculate the reflection vector of our light source based on the light vector and the surface normal. And the way that we do that is we're going to say float 3r equals reflect, whoops, get rid of that space, the light vector and the normal. So that's going to give me a new vector that is the reflection vector. So if we have our light source coming in, our light vector, and we have our surface normal pointing up out of the surface, this built-in intrinsic function, reflect, is going to give us, it's kind of like the opposite vector from the light. It's the reflection vector. And you can see that in this diagram here, how the reflection vector, if the light is coming in from kind of a steep angle, the reflection vector is going to be really steep as well. But if the light is coming in from a shallow angle, the reflection vector is also going to be really shallow. So as I said, reflect is calculating the reflection vector for us. There's some pretty complex math in actually calculating this, and so it's nice that HLSL has this built-in intrinsic function, so we don't have to actually do the low-level math ourselves. Now, in our case, we actually want the negative reflection vector in order for our Phong reflections to work correctly. Okay, the next thing that we need to do is this line says n.h. And actually what we're doing now is r.v. And so I'm just going to comment this line out. And just like the one above it, I'm going to type float r.v. So we're doing a dot product between our reflection vector and our view vector, or I vector. And this allows our viewing angle to influence the appearance of the specular highlight. I'm going to say equals saturate, and again we're clamping it between 0 and 1. Saturate dot R and V. So there we've got our R.V term. And the next thing that we need to do is calculate the glossiness. So this line we're going to leave here. And then finally we need to compute our spec power. And instead of N.H, we're going to use R.V. And actually, I'm just going to comment this one out. And I'm going to copy it. And I'll paste R.V. There we go. And then our specular, the final result of our specular is computed the same way. Spec power times spec color times specular texture. Let me grab these lines and just kind of move them out of the way and consolidate things a little bit here, so we can just sort of clean things up and get a good idea of what's happening here. So in the case of Fong, instead of computing our half angle and then doing the dot product N.H, we're computing our reflection vector and doing the dot product of R and V. So just a slight variation there. And I'll just go ahead and consolidate this code. And so there you have it. This is the Fong model of specular highlights. So now let's jump over here to Max, and we'll take a look at our teapot. So this is the Blinn version, and I'm just going to crank this back down to say 35 or so. And what I want to do just really quickly is show you the differences between Fong and Blinn. So here's my material with the Fong shader assigned to it. And you'll notice I've got my glossiness set to a value of 4. So it's quite a bit lower. If I set it to 1, for example, can we go lower than 1? Let's see. Come back over here to the Fong, and let's see. I want to set my glossiness min. Let's say 0.01. I just want to experiment with this, because what I'm seeing here is that with Fong, if I go to, whoa, look at that. We just created like a toon shader or something. Okay, that's kind of crazy. I guess you don't want to go lower than 1. So with Fong, you start out with a much tighter highlight. So if I set this to 4, for example, I've got a pretty tight highlight already. Let's switch over to Blinn and set this to 4. And you'll see that with 4 on Blinn, my highlight's really broad. So for example, if you're doing some kind of brushed metal or something, you could set this to 2, and your specular highlight spreads out a whole lot. But with Fong, with 1, I still have a pretty tight highlight. So in my experience, it's best to use Fong for surfaces like plastic, like shiny red plastic. Whereas if you're trying to do metal, Blinn is a good lighting model for metal. There are better lighting models for metal, and we'll talk about that in an upcoming chapter. But for now, let's just say Fong is good for plastic, and Blinn is good for metal. Now, another thing that I wanted to show you is how the specular highlights behave when you come around behind them. So this is our Blinn highlight, and you can see here's my light source, and the specular highlight is kind of streaking away from the light source. Can you see how it kind of narrows to a little bit of a line there? That's kind of an odd behavior. It may be what you want though, because maybe a metal surface really does act that way. Now, I think that the specular highlight on the Fong is a little bit more natural. So here we are around the front, and what I want you to notice is that it spreads itself out quite a bit around the edges of the back. Now let's turn this up a little bit, because going as low as 1 is probably not what you're going to want. But if you look at objects, take a shiny object for example, if you look at it straight on, it's less reflective, but if you look at it kind of at a glancing angle, you'll notice that objects have a tendency to be more reflective the shallower the angle is between your view vector and the surface normal. So if you're looking at an object straight on, it's less reflective, but if you kind of turn it at an angle so your view is parallel with the surface, you'll notice that objects are much more reflective. And this Phong kind of simulates that. If I'm looking at it straight on, my highlight is here, and it's relatively small, but as I turn it around, you see that it kind of spreads out along the edge. Can you see how it's spreading out that way? That's a little bit more natural of a phenomenon for the specular highlight. So an interesting effect. Anyway, so we have two different alternatives for calculating our specular highlights. We have the Blinn specular model and the Fong specular model. So in the next couple of chapters, we're going to talk about some additional lighting models and what the code looks like for those and what their strengths and weaknesses are.